Good morning, everybody. All right. Just a bit of a recap from yesterday, because a lot of everything we're talking about here is based on plasma and plasma's effects on matter, liquids and gases, really. One of the, primarily the most thing you'll see when it comes to plasma, everybody talks about the gas stage of matter. And when the gases are excited... Is
that the Czech way to say it?
Pardon me?
Plasma?
Yeah. Whoops. Yeah. When the gas is excited...
New state of matter.
Yeah.
It's a half-assed one.
Yeah, exactly. But plasma in liquids is also quite an interesting phenomenon that we'll be looking at this weekend as well, and the effects on the solids. The sun. This is a picture of the sunspots over the last year, over time, all interlaced on each other. So it's really interesting to note these two bands where the sun goes through. And Bob talked about global warming yesterday, and this is the graph you've all seen, how terrible it is, and this rapid increase in temperature. But this is just a small fragment of the big picture, because what they're showing you is this little sliver right here. So this is sort of the long-term history of the world. And people ask me, do I believe in climate change? And I say, yes, I do. The climate has been changing on this planet since its inception. There's also the issue with the carbon dioxide and all that too. And I have a solution for that as well. Yeah, so everybody that believes that the carbon dioxide is the problem, you just take in a nice breath and exhale and hold it. And keep holding it and keep on holding it, and pretty soon that problem will go away. So the sun really controls a lot of our weather patterns. And there's been meteorologists in the past that have observed the sun and have been able to accurately predict the weather well into the future. And we're talking about plasma and how the sun is just continuously emitting the stream of solar wind, and all this stream that comes around the Earth, and it's called the Van Allen belt, that kind of protects our Earth with its own magnetic field. And the magnetic field that's around the Earth is also based on these energies moving around the Earth, rather than looking at it like the Earth is a giant magnet that has something in the core that is emitting a magnetic field to steer compasses around. It's more about the ionic currents that are traveling around the planet.
So, Paul?
Yeah.
Backing up for a second. So as you're showing, though, that it looks like the sun is facing the sun, but we're getting tons of galactic rays from all sides.
Oh, 100%.
Through a new part of the universe. So that's...
This is a small piece of the puzzle, for sure.
It's a strong piece of the puzzle.
Yeah, it's strong because it's near. So we're orbiting around the sun, but the sun and our whole solar system is also moving at vast speeds throughout the universe itself. And about 10 years ago, the Russians started talking about something that was going to happen right now. And they said our solar system is about to move into a heavily magnetic dense portion of space. And that will have all kinds of chaotic effects. And these kind of cosmic influences not only influence the weather, but everything, all life forms on Earth. We're intimately connected through our own bioplasma fields, which we'll look at a little bit more today. And everything is intricately connected through plasma, basically.
And Paul, just to point out,
Yeah.
briefly, it looks like the human body. I presume you can see that. You see the head and the arms forming. Mm-hmm. So this is the sort of the soul fractal. That's our energy field, and it's like that in our solar system, which is why we look this proportionality.
Yeah, we're really going to look at that today because everything is fractal and recursive. And how we mentioned yesterday about plasma is capable of taking on form. It's the shape and the geometries in these things that influences the life. You've probably seen the experiments from Hans Jenny where the cymatics, where he takes a bow on a steel plate with sand or lycopodium, and it forms the vibration, the sound, forms patterns. These patterns, as we're going to see today, influence everything from cosmic, large, massive bodies, all the way down to small substructures, the human body, the DNA within the cells themselves, and all the way down. So as the alchemists of old said, as it is above, so it is below. Because everything is fractal, and these patterns repeat over and over, and it's recursive, so it repeats on down.
Don't they also say so within, so without?
Yeah.
Something like that?
Yeah, absolutely. We live in this duality nature. And this duality is seen everywhere in nature. So all the things that we're discussing are just observations of nature. And the more we can observe nature and work in harmony with nature, the more efficient machines we're able to make, the more we're going to understand how our biological functions work, even our mental and spiritual aspects of ourselves work as well. So you've probably all heard this concept of the Coriolis effect. So these counter-rotating spiral fields are what moves the air currents around our planet. And interestingly enough, the plasma sort of falls in line with this aerodynamics as well as hydrodynamics in fluids. Depending on the density, we're looking at liquids and gases. And again, we see these repeating patterns over and over again. So as the plasma is being emitted by the sun, we make this sort of bubble effect. And just like in fluid dynamics, if you were to move a sphere through the water, you would see the same, put some food coloring in there, you'll see the same patterns forming around the earth. And these currents come into the earth, and the amount of energy in them is massive. So you remember how I said yesterday how we live in this infinite sea of energy. When you look up in the sky and when the sun is active enough to cause visual plasma on our planet, there are just billions and billions and billions of watts of power streaming into the earth through the poles.
Tapes that were made to measure.
That's right.
What we're looking to measure, right?
Yeah, and we're going to look at one of the early pioneers of these measurements, Christian Birkeland, shortly. Christian Birkeland, and he was laughed at when he proposed this, as well as elements coming into the earth from the sun. So we have all these stories throughout history, like the Great Flood, where it rained for 40 days and 40 nights all over the earth.
Can I interject at that point?
Sure.
So, one of my former directors of the MFMP, he said something to me a couple of months ago, which now appears to be obvious. When you have a corona mass ejection, you have a large number of ions and electrons and actual protons. These are the core of a hydrogen atom thrown out into space. And fortunately, almost every time that happens, we don't get hit by it. And they vary in size. But imagine if we got hit by a very massive corona ejection. Yeah, so something coming out and it just, rather than just the normal flux, you have basically a huge mass that escapes the gravity of the sun and just comes and hits the Earth. If that's got a huge volume of protons, what is in the upper atmosphere? Ozone. You did remember what I said.
Yeah. Oxygen.
So you combine the protons with ozone and what do you get? Water.
Water.
So you can have a vast amount of water in the atmosphere, and because it's so high up, it can take years to come down. But the water itself is extremely good at reflecting and trapping, depending on whether the heat's already here.
Yeah.
Temperatures, so you can have a flash cooling and then flash heating, and as the water comes down, obviously we're talking vast quantities of water. And at the conference Cosmic Summit a couple of months ago I was presenting at, there was a guy called Robert Schoch. Who knows Robert Schoch? Okay, why do you know Robert? Well, you know him because you were there.
Well, I heard him on Joe Rogan, and I don't remember much if I watched too many things, but yeah, I know the name.
So he's famous for the bathtub where the Sphinx is. And that when he went there, I think in the 80s, was it the 80s or 90s?
Yeah.
Something.
Even earlier.
Yeah, maybe.
80s, yeah.
He noticed as a geologist that around the bathtub, the stone had been worn away by what can only be water, because wind has a different erosion pattern. And based on that, and based on the known historical records in other methods of detecting this geologically, they knew there wasn't much water in the last 7,000 years. So this must have happened a long time before. And this put the Sphinx, not the pyramids necessarily, but the Sphinx, you could age it more accurately in the sort of 11, 12,000 year period. And he was highly ridiculed for this. But of course, this is the time of the Younger Dryas impact, where they think it's an impact, but he was proposing at the conference that probably wasn't impact. It was probably a coronal mass ejection. And that a vast amount of flash heat came first. It melted, or afterwards, it melted the ice caps. But then he didn't consider this, but it's another possibility. Water was synthesized in the upper atmosphere, and over a 2-3 year period, the sea level, with a combination of the melting of the end of the ice age, like a sudden ending of the ice age, and the extra water, you ended up with the water rising hundreds of meters in years.
So the micronova then is a larger CME, is an actual magnitude? I mean, I know.
Yeah,
but it's an order of actual magnitude, right? That's what you look at.
It's enough to do what it did. And the question is does the planet have a relationship with the sun such that we go through a 36,000 year cycle, and the sun just farts every now and again and cleans the planet?
Exactly. Yeah. Yeah.
So the moral of the story is we should be wearing those triangular.
One more question back.
What was his name?
Robert.
Yeah, Robert.
Robert Schoch.
Oh, I thought you meant your name.
Yeah.
Yeah. Okay. Great. Yeah, absolutely. So we have this intimate connection with the sun, and if it's you know, the case where there's been a thing about consciousness and what is consciousness, what is our memories. I believe that everything is contained in the field around us. You know, scientists say it's, you know, not in your head. There's something more beyond it, some kind of quantum connection. But it's in the fields around us. So anytime that these fields are affected on the Earth or individually as a body, a biological being, it heavily influences inside. So all the way down to the DNA. So the missing link in the theory of evolution could have also been a coronal mass ejection that created radiation to manipulate DNA over time. So when we look up in the sky, and this latest solar activity has been quite active, you've been able to see the northern lights all the way down into the southern states. I'd imagine you guys probably seen them here as well. Right?
In the UK, you could see them a few weeks back.
Yeah.
We can see.
Yeah, yeah. Mm-hmm. And they're just spectacular. You can even hear them when they're really intense. And they sound like sheets of crackling ice crystals.
That's in Florida, they came that low.
Right.
People are going, oh, how pretty, and they really knew what that meant.
Right.
I don't think they'd be so admirable about how pretty it was.
Right. So the sun goes into these 11-year cycles where the poles on the sun can flip back and forth. The sun also goes multipoles at times. And if this is affecting our consciousness, then it's part of our conscious evolution that we are evolving along with the sun. And if you go back to ancient Egypt, as we were speaking earlier, the Egyptians believed that the sun is actually like a being, and when we die, we can become stars and suns ourselves. So inhabiting the consciousness of an entire sun. The idea of Gaia and our planet being a being or an entity, and all the flora and fauna and everything on the earth itself is kind of like all the microbiology that's happening inside our body as well. Our cells, we're only 10% human cells. 90% of the cells in our body are other things. Fungi, bacteria, viruses. Viruses are sort of code keys for locks, for changes. And they can adjust the DNA by drilling RNA strands into our cells. But all those things have a symbiotic relationship inside of our body. And all those things, as we're going to see, are intimately connected with the sun and the cosmos beyond. So this is an instance of a plasmoid that's a rather large plasmoid. So if you visualize these coronal mass ejections, the plasmoids are capable of being very large. This would be a large one that gets formed in a bubble around the Earth, or very, very small. So these coronal mass ejections are made of teeny, teeny little plasmoids coming towards the Earth. So what is a plasmoid? The word plasmoid was coined in 1956 by Winston Bostick. It means a plasma magnetic entity. So a combination of the plasma and the magnetism. Because the plasma itself will react to magnetic fields. And in certain configurations, it creates its own magnetic domains and fields. So a plasmoid is a coherent structure of plasma and magnetic fields. They've been proposed to explain natural phenomena such as ball lightning, magnetic bubbles in the magnetosphere, as we saw that bubble on the Earth's movement there. The tail of comets, the solar wind itself, the solar atmosphere all around the sun itself. And when we produce them in the laboratory, they can include field reverse configurations. Because the complex geometries that can be formed in plasmoids, they can be made up of pure electrons or purely ions or combinations thereof, capable of forming extremely complex geometries. The plasma that's emitted is not just an amorphous blob, but most particularly in the plasmoids we're talking about here are in toroidal rings, when the magnetic fields sort of fold into themselves and form the torus. So we call this toroidal structure a plasmoid, and we're going to be using that term quite a bit, or the fractal toroidal moment. As Bob says, I like this concept even better. Like plasmoids really just defines them really well. And what's happening in that toroidal moment is fractal because it can be, as we'll see, very large or very small. And we see them, on a cosmic scale when we look at supernovas and galaxies and everything far away, all the way down to nanostructures, liquid crystals and ultra cold gases and very, very small structures. Although the topologies of vortices and monopoles are distinct from one another, under circumstances, a monopole can spontaneously and continuously deform into these vortex rings. They have curious properties. They can form these monopoles and anti-monopoles.
Could you do me a favor and just define monopole for my group?
Maybe Bob can step in. Because I know he's...
Actually, one of the videos I'm just pulling, my previous presentations that I'm pulling slides from right there, is called The Monopole Clutch. And Kenneth Radford Shoulders, who I spoke about yesterday, Kenneth Radford Shoulders, the inventor of microelectronic screening technology. He described at the end of his 1986 book, 87 book, EV, A Tale of Discovery, that the exotic vacuum object, as he finally called it, which is this toroidal plasmoid type thing, was an oscillating monopole. What did that mean? You have charge plus, minus, yeah? And Dirac postulated, I think in 1932, Paul Dirac, he's a famous British physicist.
The Dirac equation.
Yeah. That there would be symmetry in magnetism as well. And if you can find the monopole, then it opens up a completely new world of physics.
So is the monopole the symmetry?
So normally people understand that if you take a magnet, it has a north and a south pole. If you cut that magnet in half, what happens?
Two.
And you get another north and a south pole. A monopole would be where it's just a north from all directions, essentially, and just a south from all directions. Mm-hmm. Now, recently, a group at Aalto University in Finland, 2009 theoretically, and 2014-15 practically in condensates, coherent matter. They have created what's called a topological monopole. And this is essentially doing the function of the theorized Dirac monopole. And it allows access to a whole, as I said earlier, range of physics that would not be possible without it.
Yeah.
Does that answer your question?
Excellent.
I've just asked to define it, so that's
Yeah.
good.
Yeah.
Yeah. Okay. So there isn't a particle that is a monopole. There's a collective effect that leads to something that behaves as Dirac predicted.
Right. And what scientists have been saying for years, like Dirac, if we can crack that nut and figure out how to take control of those monopoles, it opens a whole new world for science. This is a device for creating sonoluminescence. And inside of this flask is just water. And there's two ultrasonic transducers, 90 degrees out of phase. So they're putting sound vibration into a round vessel of water. And when you match the geometric resonance of the sphere, you get this tiny bubble inside the center. It's a bubble of expanding and contracting cavitation. And this bubble is expanding and contracting at speeds of like Mach 6, very fast. And it's moving so fast it's emitting light. It's a tiny little star forms, visible plasma. It's a simple apparatus to build. And this is how we were kind of doing it in the early days. And now you can do it with a single transducer now as well. But basically, you had to listen to the resonant frequencies and then tune your frequency of your ultrasonic sound waves to meet in the middle and cancel each other out. And they collapse into counter space. And from there, this bubble appears.
Is that the zero point, or is it a scalar type of thing?
Exactly. Yeah. So this idea of the scalar fields, and when you have two opposing longitudinal waves, because the longitudinal is moving not transverse but in packets of compression and rarefaction, just like sound. So my voice is the air is being excited by my vocal cords, and the compression and rarefaction is happening in the air between you and I and your ears. And your eardrums are vibrating with that vibration. This is a longitudinal wave that's coming from me to your eardrums. And then your brain is interpreting the signals on the nerves from your eardrum. So this cavitation bubbles start small and start to expand. And we see cavitation, it's been a big problem in hydrodynamics for many years. Everybody's seen the propeller on a boat, if you've owned a boat, or you see the back of the boats. And the propellers get all these little pits in them, little holes. Those pits are formed from the high intense energy that is emitted from these cavitation bubbles. And they're essentially destroying and eating the metal in the propellers. So the Navy has spent, millions of dollars of research over many years to try and figure out, and many people have in nautical type systems to prevent this from happening. So yeah.
So for America, basically the Navy was the military for a long period of time because it's a nation that has two big oceans on either side, and there wasn't any aircraft. So the Navy was the major research organization, and one of their biggest problems was cavitation in the means by which they propelled their craft. And a lot of work has gone into understanding what cavitation was and is. And essentially, the understanding of cavitation with what's called the re-entrant jet here. So,
I can get that for you.
Okay, so a cavitation bubble is formed, and then when it approaches the surface, let's say this is our turbine or our propeller or impeller, there's a different pressure regime here to between here. We'll talk about something similar with the push model of gravity, okay? So you end up with more pushing on this side than you do on this side, and so you get an asymmetric bubble collapse, and this accelerates and accelerates and produces what's called a re-entrant jet. And this can go so fast that it can penetrate into matter. Now, what no one has ever done in these drawings is considered the fluid dynamics that's going on in this process. Because if I have something shooting down here extremely fast, what's going to happen? Well, you're going to have shear forces in the fluid in here, which is a gas, let's say, and it's going to cause a vortex, and it's actually going to be a soliton. Okay? And that persists. Now, in more recent work, where you can see high-speed photography, you can see actually the production of a number of solitons in this process. Now, if you have a resonant place where there is regular cavitation, and the soliton is spun, and it's spun, and it's spun, it creates the same kind of thing that goes on with a lot of so-called alternative energy or free energy devices. You will get a chance to see it in action, okay, and do the experiment yourself. So our project has gone way beyond what is common knowledge with how cavitation works. Cavitation has been shown to transmute matter, but the model, in my view, wasn't just about smashing things together.
Yeah. Excellent. So you remember the counter-rotating vortexes. You see them are within the toroid if you sliced it in half, counter-rotating until it reaches great speed on this outside edge and finally comes in through the re-entry jet. And if
you can go.
Okay, so
theoretically.
Not theoretically. Not theoretically.
Well, it's actually happening now within ourselves. Yeah?
For sure.
Yes.
Okay. These kind of processes happen at every scale.
Okay.
When you have a gas here and water here, water is a polar molecule. Okay? And around interfaces, the polar molecule arranges itself such that you get what's called a space charge, or an area where it's either more positive on the inside and negative on the outside, or more negative on the inside and more positive on the outside. There's also, when you have it next to a surface, water will arrange, if it's a hydrophilic surface like a metal, it'll arrange such that you get a thing called easy water, where there's more negative charge next to it. And this goes on when you expose yourself to sunlight, and the particular frequency of IR allows for blood to flow better in your veins. It's that kind of process going on. So if you can imagine, we've created a vortex here, and we have a charge differential on the boundary. That is current going round in a loop. Okay? And that creates a magnetic field. And that creates a toroidal moment. Okay? And the toroidal moment is able to do the magic.
That's how the heart works, right?
The heart is a toroidal moment structure.
Yeah.
And the brain, as I will show you, and it's been proven with functional magnetic resonance imaging, fMRI, is producing toroidal moments as well. And you'll understand later how this allows matter manipulation, telekinesis, these kind of things.
So that connection between the heart and the brain, same thing happening in the synaptic systems in the two hemispheres of the brain, as well as the chambers in the heart. And all your arteries have nerve endings that coil around the arteries themselves. The blood contains iron in it. These structures, releasing a lot of energy, produce currents that are flowing through your blood and your body, can be induced onto the nerves that coil around your arteries. So essentially, this braiding effect that happens in these toroidal fields, if you were to wind a coil in a toroid, it contains the magnetic fields in a special way. This is why we use toroidal coils in radio frequency transmitters and things like this. I use them inside of the Therify. We'll talk about that in a bit. But also the same spiral we see in the DNA itself. So the DNA being made up of two strands that hold together these A, T's, C's, and G's. These are all amino acids that form these ladder rungs all the way through the DNA. And a single strand of DNA is about 7 meters long, from here to the back of the room. And it's too long to obviously be straight inside of your cells and maybe sticking out all over the place. So they have to figure out how to compact very efficiently. And the most efficient way is to twist and twist and twist till they sort of braid, and then they, like a rope, when you take a rope, is everybody taking a rope and twisted it so much that it starts to knot into the next section where it forms a spiral now. And then you continue to twist and twist and twist the rope, and it'll knot again. And it'll start to twist around and it'll knot again. The DNA will twist and twist and twist around until it forms a little toroidal, compact segment. And that twisting happens throughout the universe as well, with the long strands of plasma, and they form into these fractal structures. So this is part of the fractality in the DNA itself. And then that can unwind very efficiently. So it never gets tied in a complete knot where it wouldn't stop. And that's a big part of biological processes is proteins and how proteins fold. Misfolded proteins cause trouble. And when they don't match and you have a misfolded protein, things can go wrong. We've seen this for the last few years with all the spike protein stories on the coronavirus. Again, the corona, the reason why they called it the coronavirus is because you've seen that little picture of the virus with all the little spikes coming off, just like the corona. And that's where we get the word crown from, for royalty and the kings, is corona, like St. Elmo's fire. The idea was that they were emulating the sun and the sun's field around it. And the god Apollo, and you've seen all those alchemical pictures of the king with the corona around his head. All ties into this. So those spike proteins, now we have modern science that's able to manipulate those things. And essentially that's what's been done to cause those. Because the coronavirus has been around for eons. It's the common cold. And they've known that for a long time. And they actually wrote papers on it back in the 70s and 80s on how can we misfold those proteins and weaponize a biological weapon to make from them. So, fractality, infinite patterns that repeat over and over again. Just like time moves in cycles and we seem to never learn because we repeat the same old patterns when we slowly move. So if you picture time rather than being a linear constant, visualize it, I like to visualize it more as a spiral. So patterns can repeat however it moves forward. And it can condense and compress like the knotted rope in the DNA and expand. So the protium that we're talking about is just a single proton, and hydrogen, H1, is a single proton with an electron. And they don't like to be alone. Hydrogen is always paired up as a H2. That's how the common gas is. If we had a single proton or a single atom of hydrogen, it's very active and very anxious to get with another hydrogen. And so this would be called a monoatomic hydrogen. And if we add energy into H2, we can split them apart and utilize that. In electrolysis, in basically all this cold fusion processes all started with electrochemistry. And when we make an electrochemical cell and we have just water in there, you have plates of positive and negative plates, and it will pull the water molecules apart because they're polar. The hydrogen gets pulled off to one side and the oxygen's to the other. And we'll look at that a little more in a bit here. So then the next isotope of hydrogen is deuterium, 2H, which has a proton and an extra neutron. And this is heavy water. This is what comes as a result of doing nuclear reactors in the water they have in the system generates a lot of heavy water. And a certain percentage of the water on the planet contains these deuterium. And it's a little bit heavier, something 20% heavier. So if you have 1 liter of water, pure water, it weighs 1 kilogram. And you can measure the amount of deuterium in it by just weighing an accurate volume. And the third isotope of hydrogen contains 2 neutrons. And this is so active that it actually emits light constantly. Do you know the half-life of tritium?
Yeah, 10 point something years.
Yeah. So it's a short-lived reaction.
Till it
decayed until it breaks down and decays. But you've seen them, picture like a glow stick or whatever. If you were to see a little jar of tritium, it looks like a greenish glow, like from those glow sticks. As it decays.
You can actually buy them.
You can buy them in the little keychains.
Yeah, and they're meant for putting in emergency exits, because they would illuminate the exit for, say, half-life doesn't mean it stops producing beta at the end of the half-life. It means it produces half as much as it did when it started.
Yeah.
So one of these vials placed into exit sign will work for 20, 30 years.
Yeah.
Enough such that when the lights are out, you can see where you need to run.
Right. So this is a computer scale model of the omniverse. And notice how everything is all connected through these channels. And we see these patterns again, over and over again. Every star is connected to every other star through a light tube. Not only just the visual light you're seeing, but plasma threads that move through space. And they usually move in these pairs that twist on each other. Just like the DNA, long strands. And these long strands of these plasma light tubes are capable of transmitting information. And they're capable of storing information. They feed off the energies coming from the stars. They have an intelligence. So the idea of them being conscious would make them the largest, massive, some of them are, millions of light years long. So we talk about intelligence and consciousness, and we think it's all just in here. But the alchemists of old said that everything has a consciousness. Everything exists in its own time. So insects have short period lives, plants, medium, rocks and minerals, long lifespans, millions of years.
Is this possibly related to our fascia in terms of how it's conducting? Yes, and a lot of the other biology inside of us, because it's a form of this twisting, right? That's what reminds you of how the ribs and everything's connected in all our nervous system. There's a new organ that was recently discovered. And when they do surgery and they cut you open, and they're in there moving organs around and stuff to get at things, there was always these long, thin strands that looked like cobwebs. And of course, the surgeons of old were just like, oh, what is this strange stuff? Get it out of the way. And they'd put you back together. But those threads now, they're actually classifying as an organ, and they are tying everything together all inside of you. Yeah, it's a matrix, and it's all communication, and light can move and information can move through these matrices.
In Chinese medicine, I hear about it. It's called, tendons and the ligaments, is, a general term for the same thing, which is controlled by the liver, the wood, and that's the Chinese medicine nervous system. They didn't technically have a nervous system, but they had this.
Right.
And it's the same functioning with coordination, electricity, and all governed by the liver. Yeah,
and we think about the energetics and the meridians and the lines, energy channels that move throughout the body. They're well tapped out in ancient times. One of the oldest bog men that they found of a early man that was frozen in a bog in the Ice Age, they had found with tattoos marking the acupuncture points along the meridians. And he had a bag of herbs, and in there he had mushrooms and cannabis.
He had chaga.
He had what?
Chaga.
Chaga. I think he had appellatum, sort of a reishi. Okay. Yeah. Ganoderma appellatum, because they use that as called a tinder conch, and you drill a hole in it, and it comes out like fuzzy insulation, the mushroom. And with the flint and steel, you can start a fire with that fuzz.
And you keep it.
And then you could cut the coals and you put it inside of that tinder conch and strap it to your belt, and you carry your fire with you. So it was an efficient way to transport fire, and you didn't have to rub two sticks to get her going and spend a lot of energy. Again.
Ganoderma appellatum. Artist's conch or tinder conch.
Polypores, you can do that.
Yeah, well, most polypores are very woody.
Just one question to add here. Is the fascia that are surrounding the muscle tissue related to that tissue that's around the organs? And
Yes.
is that
Yeah.
It's the same
Yeah.
thing.
Yeah.
the same thing?
Right.
Okay.
And then in Eastern philosophy, the concept of these energy centers of the chakras and the nadis. And it's a lot more complicated in the Indian system. The nadis, there's thousands of them that come out of every chakra, and they spiral and twist in the pictures you'll see of them. But they're energetic centers that we as humans, if we are able to really understand ourselves, who we are and what we are, and we mastered our internal energy systems to use those powers inside, we have infinite potential of doing so many things. All the things we are talking about here this weekend, once we really grasp these things and we have the ability to become super human beings. We're already light beings. We call ourselves humans. And the hue is tones of color. And these bioplasma fields that we have all around us, when we're talking to each other and we're communicating through our eyes and we look at each other in the eyes, energetic photons or bioplasmas are communicating back and forth, telling way more information than we ever could vocally or think about mentally. So the mycelium and fungi is another great fractal example.
Yeah, I mean, it's just talk about heaven and earth.
Yes.
Macro and micro, your electrical pattern of the galaxy.
This
here
is
the fungi kingdom and the planet.
Yeah, mega parsecs, like this is infinitely zoomed out a picture.
Just one little thought with would you say that this communication that's going on is it's not like sending a pulse. It's an instantaneous ding at the same time in the universe.
Yeah. This is the spooky action at it. Yeah.
45.
Cost me $20. You're right on time.
This is what Einstein called spooky action at a distance when quantum mechanics started gaining some understanding into it. And how I spoke about the longitudinal waves. If you have a line of billiard balls all stacked end to end, and you tapped on one end of the billiard ball, the other end of the billiard ball moves at exactly the same time. So this idea of this communication through quantum entanglement is the way to visualize that. And it's the same in the forest with the mycelium that surrounds everything. Underneath each one of your feet when you stand in the forest, there are 1 million miles of mycelium underneath that foot, because these are very thin strands, just like the thin strands that are in your guts. They're microscopic. You can't even see them. If you had a single strand of mycelium, you wouldn't even see it. Just like the DNA. And these patterns repeat on Earth over and over again. It was just...
Translator's just gone.
So this is the example of the twisted rope that I was talking about. And this happens in plasmas. And because the plasma is a conductor, when it starts out, it has a lot of resistance. So there's a dark plasma, there's different stages of plasma. So first there's a high resistance, and as that resistance breaks down and the plasma moves from a dark plasma and molecules start to align like the billiard balls, and they start to emit the photons and become very active, then they become really good conductors. So you can instantly go from no conductor to full conductor. You guys okay? Should we take a little bit of break, or you can keep going? Okay.
Oh, no, keep going.
Yeah. So what's happening in the plasma, as it becomes more of a conductor, it generates more of a magnetic field around it. So when you run current through a wire, I'm not sure if I got, we'll get to it. When you run current through a wire, there's this right-hand rule that as the current moves in one direction, it forms a magnetic field at 90 degrees to the thing. So basically, as the plasma gets more, gets less resistance in it, it becomes more of a conductor. So the impedance is high to start with, and it will resist current flow. So plasma acts like a wire where it can become a conductor. And as current flows through the plasma, it creates a magnetic field at 90 degrees. And those fields start to interact on the next segment of plasma or itself. And that's how it winds into these forms. It's the same with the DNA. And it's all charged. When you get down to the fundamental principles of physics and chemistry, it's all about charge. So we basically live in an electric universe. All of this is purely electrical phenomenon. And they can braid until they start to wind in on themselves, like we said with the DNA. Dioctone instability, they're describing here. And this will happen on a galactic scale or on a nano scale, beyond microscope.
Do you want to explain that last slide a little bit more? Just a little bit more?
Yeah, basically it's just, yeah. It is. Are you familiar with the term itself?
Yeah. Well, basically it's something that they have noticed in plasma where, and it's a real problem in tokamaks, for instance.
Right.
And anything that's got charge moving, where it tries to self-organize into these turbulent structures that then are quite persistent.
See, these are vortexes.
Yeah, and they call them magnetic islands in a tokamaks. They're like little magnets, and they cause a problem with the stability of the plasma. And diacatron is just, it got that name, so it's kind of a name and it has some sense to it, but it's just a self-organizing of the charge structure. And it's a real problem in plasma physics.
Asymmetrical, random,
well, the most important phrase in this whole thing here is order ab chaos, or order out of chaos, right? The motto of the Freemasons. Basically, there's no structure, it's all chaos. But nature, like it abhors a vacuum, it abhors chaos. So it starts to organize itself, and when it does, in these, out of the turbulence, out of the instability, you get order, and that order produces these magnetic structures.
Mm-hmm.
Yeah.
So they don't last long, or
they last long enough to be a real problem.
Yeah.
But we actually rely on this. We're working with what nature wants to do in
just
what
going
we're
along
doing.
with it instead of fighting it.
What we want to
Yes.
do.
In a tokamak, for whatever reason, they realized that toroids seem to be important. So they thought, well, if we can get plasma, and also because you can arrange magnets in a way that a toroid is a minimum surface structure for the volume. And because you can make coils like around something, you can then make coils and magnets arranged around a torus all the way round. So the torus seemed the logical thing, but what they're trying to do is force something that wants to make its own shape into a shape that we think it should be in.
Exactly.
Yeah?
Yeah.
And nature's got its own plans.
Right.
And
exactly.
you cannot get it to do what it doesn't want to do.
Yeah.
Yeah.
And the plasma has a mind of its own. So the idea of just building one giant perfect donut, it just doesn't work that way, because as soon as they form that big ring with the magnetic fields, all these instabilities happen, and wheels start spinning within wheels, within wheels, within wheels, and then they lose control of it.
In like a simpler way, could you define like why you consider it a problem that they were doing this way?
It's a problem because they weren't expecting it. They, oh yeah.
Okay. All right, so
First of all, just repeat the comment. A bit louder.
Yeah, why is this, you know, a problem?
Why is it a
Like, in
problem?
simpler terms.
Yeah.
okay, so if you imagine you've got a homogeneous temperature and you're trying to focus the energy into the center, and you're looking at millions of degrees to compensate for the gravity. So rather than trying to get things to come together gravitationally, you're trying to smash them together to replace the gravity that you haven't got via temperature. So kinetic collision rather than forcing it together. Yeah, you try and keep that in the center channel. So the magnetic confinement is trying to keep it away from the walls, because typically your choices for the walls are things like tungsten, the highest melting point metal. Okay, the highest melting point element is carbon, right? So you make the walls of tungsten. Now, if you have these magnetic instabilities, what they don't understand is they self-organize into what you're going to learn about, which it makes what Ken Shoulders called an exotic vacuum object. It's like a normal vacuum object would be an electron or a proton or an atom of some type. And a proton, for instance, whilst it has a charge expressed from it, it doesn't have an oscillating charge, okay? It doesn't emit EM waves, it's just got a charge. So you can manipulate a proton and you can manipulate electrons because of their charge. But what these things do is they form it into what's called an unipole structure. And this particular structure doesn't have, it has a boundary called a non-radiating boundary. So it's like a bubble in space. And from that bubble in space, it does not present any electromagnetic fields. So it is not possible with magnets or electric fields to keep these things confined.
Exactly.
And so these things form. They form this self-organized structure, which is a wheel within a wheel within a wheel ad infinitum. Then it forms a bubble around itself, and then it says, sod you, I'm going to do what I want. And it goes off in this direction.
Shields up. Yeah.
And when it hits the wall, it produces what they call a unipolar arc. All of the electrons and the ions that are trapped in there start breaking up, and they will start consuming the tungsten. In one of my slides, I'll dig it out since you asked the question. In Russia, at the Moscow Physics Institute, they showed where a tungsten plate from a tokamak was hit by something, and it produces what looks like a, how should we say, it's like a mushroom growing from the center out with loads of little branching. It's like lightning growing out from a center point. And the wall of the reactor, therefore, is very damaged. So essentially, you kind of want to avoid these dichotronic instabilities because they produce things that actually most physicists don't have a clue why they can do what they can do, because they don't understand how they can leave the center of plasma, because they got these fantastic fields, and why is it doing that? Right.
And is that in a non-principled manner, like predictably unpredictable in terms of size and timing and
So,
how they are forming, like it's just so random?
So the predictably unpredictable, yes, but there is sense to it. Okay, so they have some level of predictability. They have a certain scales that they can quantize to. Very specifically, one of the basic scales is 1 micron according to Ken Shoulders. I believe it's actually 1.1 micron. And then it's around about 5, then around about 20, then around about 100, then around about 400, then around about 1.6 millimeters, and so on. So you get these quantized scales. They are scale invariant in terms of their property, but the magnitude of the properties can increase. So by that, they always look the same as you go down and down and down. And as you go up and up and up, they always look the same. What they can do is a range of damage or useful work,
Right.
depending on which way you're looking at it.
If you're fighting against them or allowing them to do
Yeah.
what nature does.
So where you can maybe get it predictable is whilst they don't project electric fields or magnetic fields, and they cannot be influenced by electric or magnetic fields, they can be influenced by each other, and they like to aggregate. So two will come together, many thousands will come together. They're self-organizing, not only like they self-organize, they become a unit, and then this one might want to join that, but in a different relationship. And if they're born from coherent matter, they will be quantumly connected if they're all at the same temperature. So they have this weird effect where like one can behave similar to the other one even though they've moved apart from each other. They like learn, they have their own learning from where they started from, they go off, but they still remember where they came from, if you know what I mean.
And that's what you're using in terms of.
So you can try and simulate what they are internally to manipulate them. However, there are toroidal moment structures in nature, like the planet itself. So these structures tend to want to move towards Earth. There's lots of these structures in the Earth. And they can be consciously controlled because your brain can produce these things as well.
The old lady with the broom. Yeah.
Yeah. Well, that can also be because on their boundary, if they're pulling in matter, they can condense it and produce photons and ionize air. And when you have something, not necessarily wood,
Sure.
but if the
Pressure.
if you have something, well, the air pressure, you have. They tend to move around walls because they charge the wall, and then you've got like charges repelling. In that respect, they can have that kind of thing going on, bouncing along the floor, like you said in the plane. That's in the sense of a wall lining. So they tend to do what they want to do when you look at them, if you don't understand them at all. They make no sense in that respect.
So this is another check box on the list of consciousness and what is consciousness and intelligence. So Christian Birkeland, as I mentioned earlier, was a Norwegian scientist, physicist who studied the northern lights, starting with the northern lights and then realizing that it's all contained, emitted from these fields that are formed through these plasmas, and as they become coherent and start to move in these connections from the sun to the earth. He was the first to propose that elements are coming into the earth and through this way, and the amount of energy is in large amounts of power coming into the earth. And so, yes, part of the right-hand rule, the direction of the current flow and the magnetic field and force if you're moving the conductor through a magnet, depending on the north-south orientation, will move. So this is the basis behind a motor and alternating currents with Tesla's AC motors. So as these streams come in from the upper atmosphere, and as they move out throughout the cosmos, like we saw in that zoomed out picture, it's the fields that are around the current flowing through the plasma stream that make it want to twist. And so those magnetic fields naturally create the twist in the plasma. And if you think about what we were talking about earlier about the water coming into the earth, there's this concept of the expanding earth theory. The idea that there wasn't just this Pangea where all the continents were on one side of the earth and the rest was water. That might make things a little lopsided and give us a bit of a wobble, but more the idea is that the earth is a seed crystal that started much smaller than it currently is now, and it's continuously growing as more and more matter comes into the earth.
Can I interject there?
Sure.
Okay, so yeah, this is a very important concept when it comes to how I'm going to describe what I believe gravity is. Essentially, the Earth 900 million years ago had a day of 19.2 hours. 200 million years ago, it had a day of 21 hours. Now it has 24 and getting longer. And it's like a ballerina putting out their arms and slowing down from a tight spin. Yeah, or like an ice skater, figure skater, you know, they're spinning around very fast with their arms in there and then they put it out and they're slowing down. So something in the earth, which I'll help you to understand, is capturing something that's very rarefied from the environment and it's condensing it into ordinary matter. And it's like you draw Gondwana land on the earth and then you go and you blow it up and the bits spread out.
Spread out.
Okay, so the earth is growing. It's a living organism. It feeds off the sun and the cosmos. And you're going to learn from what it feeds. Yeah. And how it does the eating.
Yeah, and if you look at the tectonic plates and you go onto Google Earth and you look in the middle of the ocean, you see that these plates are expanding and coming out like this. So the oldest rocks and parts of the earth are sort of in the shields, the northern shield and that, and as it expands, the newest part of the earth, the newest material, comes out of these faults as the plates all slide and shift around and continuously expands. So Birkeland built this apparatus to observe how the plasma interacts around the Earth itself. And he took a expedition to the North Pole to study the plasma fields, and he used electricity and plasma to essentially do that. He's also the first, came up with the first sort of rail gun, but a magnetically controlled bullet for a gun, because he worked with the high currents and high voltages. And
did he make a bullet go around the corner?
No. This might be possible though.
Yeah.
Yeah. Yeah. So there's these incredibly large fields, and he was ridiculed in his time. People just laughed at him. So here we see some more examples and how these twisting braids in the braids.
It's time for break.
Yeah.
Yeah.
So let me make a few
Blank slide.
announcements about that. Yeah. So Paul, you okay?
Yeah.
And
Yeah.